Hello and welcome back to another restoration project, and this one is once again a first for me. It's the first Philips set that I'm doing with FM in it. I've done a Philips AM radio, had 3 shortwave bands, a medium wave, long wave, but none of this category. Now these guys are very similar in size, shape and function to some of the GRUNDIGs I've done. The SABA, the TELEFUNKENs, and in terms of size, this one certainly matches the ones I've just mentioned. Now this guy is in incredible shape as far as the cabinet is concerned. The piano finish is still complete. There's very little in terms of dings and dents. This thing has been incredibly well looked after, as is evident. There are, a couple of scuff marks here and there, like that one there, but for a radio that's from, I believe this one's 1955, that's pretty impressive. Now, the problem with this is that it belongs to a friend of mine, it's not mine, and the diagnosis is that it doesn't switch on, it doesn't work at all. He powers it on, and nothing happens. So I have absolutely no idea what the problem is with this. So I'm going to treat it as an unknown, which is really what it is, and go from scratch, try power it up carefully as soon as we find it safe to do so, and then do the full Monty on it. But let's have a look at the back cover for starters. Again, very good condition, and some of the usual things. There's our voltage selector. It's at 220 volts. I'm hoping it's got one higher than that because I would like to put it at 240. This here, there's our power cord in. It's a dual power cord, so there's no earth. I think I'll be changing that to get a proper mains earth to the chassis. There's our gramophone input with ground and the signal in there. Magnetophone will be a tape deck. So gramophone, tape deck input. This is external speakers. Now there's something sort of strange. There's actually, you probably can actually connect 2 different types of speakers. We'll have to look at the schematic and see what that's all about. The reference number, 100 watts. So then we've got a whole set of drawings here for the antenna. Now this is the antenna arrangement here, and there are quite a few possibilities, I presume. This is what this is all about. External antenna and the dipole, the internal dipole. Then if you put an outdoor antenna, a different sort, you'd wire it a different way. But anyway, we'll have a look at the schematic and see what all this is about. This, I think, is for the various options that you have. If you want to use, for example, in this case, I think you use the internal dipole and external antenna. This thing is just the internal dipole. And I presume you then connect, you short that little guy there to the top so you can get some reception from the internal dipole. This thing is, if you do not use the dipole at all, you use an external antenna only, and then you're shorting that, and that external antenna is giving you FM and AM reception. So let's open this up and see what it looks like inside. Okay, let's see what we've got here. For a start, very beefy speaker over there, the main speaker, and it's in pretty good shape. There's a little bit of dust and so on inside here, but he did tell me that he'd tried to vacuum some of it out, which is a good thing. There's our magic eye over there. This is that secondary speaker, also quite beefy and also in pretty good condition. Then we go down here. The pulley system for selecting FM and AM tuning. Counterweight over there. Filter capacitors, the antenna input. That antenna is the internal dipole. I see we've got quite a contraption here. Gaussian protection of these are the ferrite rods, the ferrite antenna. This is the first time I've seen a protected ferrite antenna, which makes sense because you're trying to get the signal from the side, from the front, in line with the ferrite cores and not from the side. So this is metal to act as a shield. Pretty neat. There are, that's the first tube, second tube over there. There's the tuning capacitor. Very small little thing. That'll be the FM one, I think. Yeah, I think that'll be the FM one. Yeah, that's the FM one. That little one over there. And then alongside here, that will be for the AM. That's the tuning capacitor for the AM. This thing over here is actually something I've just looked up. This comes into one of the IF transformers, and this just explains something I read in the manual, which, by the way, I have. It's all in Dutch, but I have it. Complete service manual, which is brilliant. And it has a, you can adjust the width of the bandpass on the IF, so you make it more or less selective. And that would seem to be what this is doing, because you've got the ferrite, probably a ferrite core that goes in and out, probably with a spring down there, and this will pull it. So if I try and turn the front, it's not that button. I've got to find out which button it is, or maybe it's just not connected. But this would seem to be an adjustment for the ferrite, for the width of the bandpass on, probably on the AM and not on the FM. Now, the strange thing we have here is that usually we would have the FM inside a shielded box. In this case, what we have is the power amplifier. There's the output transformer. Those two are EL84 power tubes, and they're all inside this shielded box over here. We'll have to see how easy it is to get in there, because we certainly do have to get in there. Now, these are those external speaker connections. The power transformer, quite a beefy one. It's got two EZ80 rectifier tubes. I think they're in parallel, so it just gives it a bit more power. What have we got at the back? Not much. And, oh yeah, as usual, you see that black thing there behind that tube? That's one of the famous Philips capacitors. They seem to be dipped in some kind of tar, and they always leak like bloody crazy, so they've all got to be replaced. This does not look to have been worked on, which is a good thing. So we can really start from scratch and do a proper job on here. I have no idea if the tubes are working. I really have no idea about much at all, except what I see. So this becomes a proper restoration, repair/restoration project, starting from scratch, and hopefully taking us to the final result. And with those speakers, I'm hoping to be pleasantly surprised. I was with a Bush that I restored, and the sound on that thing was absolutely amazing. And the hint that I got that it was going to be great was the size and the quality of the speakers. And this one is giving me the same kind of idea. So hopefully that's what we'll end up with. So let me take this guy out of the chassis, out of the cabinet, put it on the contraption to make it more accessible, and see where we go from there. Having a look at how this thing's going to come apart to be able to remove it, looks like the best thing to do is leave the speakers where they are and just desolder these three wires here. Now they go black, brown and gray. So black, brown, gray. And then what I'll do is the magic eye will come out together with the dial lamps, because that's all connected to the back here. There is a problem here, and that is that the transformer is not physically connected to the chassis itself. It's connected to this wooden board here. So it looks like I'll have to remove this wooden board, and I'm not sure that I can isolate this from there, which means that I'll have to work through the opening that the wooden board provides. This in order to flip it over. So it should be a challenge. Well, that came out pretty much okay, and we can see the results of some of the cleaning that was done in here. The parts that were accessible seem to be fairly clean, but well, we do have some remnants, which is always good. It shows you that it hasn't been messed with too much. Right, we've got the guy out of the cabinet, and we start seeing a few little problems. There's a very leaky capacitor, and it does seem that I won't be able to get this this main chassis off this wooden block, because the transformer is screwed onto here, and then that's screwed separately. So if I do take this off, I've got nothing to hold the transformer on. So it looks like most of this is going to be done on that base block, which is probably fine. I think I can get to everything. These EZ80s seem to have been pretty well used. A lot of dust in there. A few of those wax, or rather the tar capacitors in there. I think the first thing to do here before going any further is give it a good clean and see what we're left with. The tuning dials seem to be fine. This is a really well constructed radio. They certainly have gone to town on some of the mechanical detail, which is great. This one is really going to be a pleasure. Here we've got that mesh covered ferrite antenna box again. Just to get a look at the detail. More or less a before, and then we'll do the after later. But yeah, a lot of cleaning to do before I even start thinking about powering it up. Right, we've got it out of the chassis and into the contraption. This is a bit of a tough one, as I mentioned before, because the power transformer is actually screwed to that bottom wooden plate and is not connected to the actual chassis. So if I wanted just the chassis on this contraption of mine, I would have to make some separation there, and I really don't want to do that. If you see all these wires in there, it's not something I want to do. Anyway, this thing, just a few things that I've noticed as I got this thing checked for power up. I've done the audio transformer test, and I've come up with some pretty bad news. This thing has got two amplifiers. It's bi-amplifier, and what they do is they literally separate the bass from the treble frequencies, and they amplify them separately using an EL84 for each, and then each of those has an output to a speaker, and those two speakers you see on the back is one a bass speaker and the one for the mid-range and high frequencies. Now the high frequency one is not working, and the transformer for that is this guy over here. The transformer for the bass is actually underneath the chassis, and I do get a tone from there, and I'll put a link on the top for how I do these tests on the power transformer, on the output transformer, I beg your pardon. And it's pretty simple and it's pretty effective. But what I have so far is I've taken out the power tubes. I've also taken out the two EZ80 rectifier tubes, and that will allow me to actually switch on power to the radio and not have it going to the rest of the radio. It's just going as far as the EZ80 rectifier tubes and no further. But I'll show you that in a schematic in a minute. Just one thing I want to show you here is, remember I mentioned that this has a band pass adjustment. You can see it going down and going up there. Now that adjusts the band pass width of the the IF transformers, or one of them at least, and that is controlled by this little wire over here, and it goes to the back there. Down there, well, you can't see it there, but what it's controlled by is actually by the tone switch, the tone control, the bass control really. So that's how that works over there. And we'll see how that works when we get this thing up and running. As for the ferrite antenna, that's controlled by this back control here. And as you can see, it's pretty effective. You literally aim this at where you get the highest signal, and this metal mesh cage really cuts out any extra noise, which is pretty cool. It's the first one I've seen with the actual mesh cage on. But what I want to do now is, okay, so far what I know is that I have a problem with one of the output transformers. Now, because I don't get a signal through there, does not mean that it's necessarily burnt out. I need to do a few more checks on there, make sure that I'm not going to condemn that transformer too early, because that is a problem. That is a problem, because finding one of these is going to be a nightmare. But anyway, what I do notice from checking the schematic and checking this power stage is they have a capacitor across the mains there, which is already leaked. Those are the so-called death caps. You're supposed to put a safety cap on there, so that's got to go. This is pretty neat the way it's set up. These are hefty resistors, 100 ohm, 8 watts, after each of the EZ80 rectifier tubes, just so that they blend in to the same B+ rail equally, or it should be equally. And what I've done also is I've checked the cap. Now this thing has got one big, this is a 3-part cap over here, 3 by 50 microfarads. What I did was I disconnected the points just to make sure it wasn't shorted and it was reading the right values, and reforming it if necessary. I found that the readings were about 47 microfarads, 46 microfarads. It's supposed to be 50, which is fine. ESR was very low. And when I did a leakage test with the capacitance leakage tester that I built, and I'll link that above as well, it started off at about 2 milliamp leakage and very, very quickly came down to about 150 microamps, which is fine. So that capacitor, that multi-section capacitor, seems to be okay. The one thing that concerns me is why that transformer is not working, because if it's actually burnt out, that could mean a few things. What makes an output transformer burn out usually is if someone doesn't connect a speaker to it. Now, the speakers, there's actually 3 connections here. I've taken one out and connected it to the speaker. I've only got one speaker on there, and it's only for the bass channel because I know the other one is not giving me that signal. And the reason I put that in is so that I can easily wire it up to the external speaker with a plug. Now, why would that burn out? Well, it's not as if you're plugging in speakers, so something else might be wrong here. And it could have to do with these capacitors. These are those big capacitors I don't like. They're tar covered. They usually leak like crazy. That could do it. That could do it. There are another 2 of those big caps. We've seen what that safety cap is doing. It's leaking like crazy. But what I'm going to do now is I'm going to show you on the schematic. But first of all, I'm going to actually power this up without the rectifier tubes in there. And I'll show you. Let's just check if we get AC voltage in there. We're not going to get the DC because the rectifiers are out. But let's see if that transformer is working. We'll do it through the light dimmer limiter and just see where we go. Now, we've got to do it with the limiter anyway because there might actually be a short that I haven't seen. And when we do switch that on, the actual B+ is stopped right by the entrance to the to the tube rectifiers, but the heater voltages are all distributed across the radio. So we've got to do it very carefully because there may be a short on the heater voltages as well. And we'll see that very quickly when we do it with a dimmer limiter. So let's set it up and get ready to do that. The limiter's got maximum limit, so there's only one light on, active, and it's off. And what I'm going to do is the radio's off. I'm going to put that on. And I'm now going to let's select medium wave. Just put the volume down. We shouldn't get anything, but let's put it on medium wave. Now, the current we'll see through there will be mostly, the inrush current will be there are no capacitors yet, unless there's leakage on that safety cap. It'll be the heater voltages. So, well, let's go. 1, 2, 3. Well, it's drawing 100 milliamps. The light went on bright and then down, so it seems to be short free. The panel light is on, one of them. First one is on fairly dimly and the other one is off. Now what I'm going to do is I'm going to measure the AC output voltage from the transformer, which will be at the input to those at the anodes of those EZ80. So connect this to the chassis down here, and we're going for pin 1 and 7. Set this to AC volts, helps. So there we go, 241 volts, 242, 7. Yep, it's getting there. The other tube, it's getting there. The other tube, it's getting there. So we've got voltage there. And now let's just check what the heater voltage is. And that, bearing in mind that we don't have the full voltage coming in, there'll be heater voltages are 4, 5. So 5.6 volts. Okay, that's really no load. 5.6 volts, and that there's reading the dimmer, light dimmer is reading 190 because of the current being drawn into the heaters. I do see some of the heaters on the other tubes lit up, but I'm not too worried about that at the moment. What I actually am going to do now is I'm going to give it some thought as to how to go a step further with that output transformer. I'm going to do some more tests. I'm going to carry on testing the power supply before I power it on with the rectifier tubes in. So when I get back, that's what I'll be reporting on. I'll see whether the power supply section is all working, and then we'll do the actual power up with the tubes in to see if we've got any reception at all. Well, okay. See you back soon. But just before I go, I'd like to comment a bit on the schematic so far. What we have here is we've got the mains coming in through that switch. It goes through this thing called a Z. Now, the Z I thought was a fuse, but it's not. It's one of those fusible links on the transformer itself that actually breaks apart if it gets too hot. So this thing doesn't actually have a blowable fuse. I'm not sure how sensitive these guys are, so I'll probably have to put a proper fuse on here. Then across the mains, this would be the other line of the mains, it's dim here. There's a capacitor, 100K, that'll be 0.1 microfarads. That's the one that's breaking apart and melting on the bottom of the board there. It goes into the transformer, the other side goes into the selector. It's at 220 at the moment, I'll probably put it at 245, okay. Then it comes out. Now we know the lamps are on, so this transformer winding seems to be fine. Some of the tubes valves, the heaters were on, and I measured the one, so that seems to be fine. It's not shorted or we'd get a very low voltage. Then we've got the center tap of the transformer to ground and the two separate windings, one going to the pin 7 of the tubes and one going to the pin 1 of the tubes. So these tubes are actually working in parallel to provide more current. This is the EZ80. They rectify the mains, or rather the output, the AC output, and the result comes out at pin 3, and it goes through a 100 ohm resistor. Both of them do, before they join up to what they call the 300 volt line here. The reason they have this resistor here is just to balance the loads of these two, because if they're not exactly matched, you would get one fighting the other, one doing more work than the other. So in this case, they're basically distributing the loads. Then we go one step further, we get into the first filter capacitor, which I've measured and checked, and it's fine. There is a 94 ohm resistor between these two, forming a pi filter, so that is the second stage of the filtering. And at this point, it then goes to the 285 volts B+, they call it plus plus plus, so that's the highest voltage. That would go to the output transformers. It goes in here, into that transformer, through the transformer, into that, and pin 7. It's the anode voltage. Now, I know this one is working, and it's actually quite fortunate that this transformer isn't blown, because what it then does is it comes through here. When it goes in, this is B+++, it goes through part of that output transformer, and this acts as a small choke to provide our plus. Now, don't forget that, because we'll get back to that in a minute, because up here we have the second output transformer where it comes in. The B++ also comes in through that primary into there, and then you have pin 7. It goes into the anode of that tube. Now this is the one where I'm not getting continuity between here and here. So there's no B+ going to go to there when I finally measure it. Now, a lot of things could have caused that, and one of them, if you think about it, could be that capacitor there. It could be that this speaker was disconnected for some reason, that I don't see how that could have happened. Anyway, we'll get to that. Actually, there's one more possibility, that a short here would cause the same problem, and it could be this switching. This is for connecting external speakers. Imagine if that point that comes from the top there, instead of going to a speaker here, got shorted to ground. So it could have something to do with this switching system, but we'll find out soon enough. Now, going back to our plus, there's our plus that comes back from that choke, goes through a 1K resistor, and it comes to the third part of that filter can, another 50 microfarads, and you get the B+, which is 250 volts. So you've got 3 levels here. That has a small filter capacitor here, which we have to check. There's some sort of switching. Usually this switch would mean powering the AM section and powering the FM section. So sometimes the voltage to the oscillator is switched off. The AM oscillator is switched off when you power FM, but we'll check what that is as well. Now this is the sort of part of the circuit that I need to check completely now that I know that I have AC voltage on primary, secondary voltage coming out, and it's going through there. So that is that. Now the output transformer, I've been thinking about what to do here. This transformer is fine. This is the transformer for the bass. This one is fine. So I can actually prepare the radio to test it just with this amplifier, this power output stage, because the other power output stage, the one up here, this one is for the highs. Now if I don't put that tube in there, if I remove that tube and I power everything up, and this thing is not getting B+ anyway, I should not have a problem. I can actually test for sound, for reception, just with the bass section, until I figure out what I'm going to do with that with that about that transformer. I might have to take it apart and see if I can't see any shorts, any breaks in the windings. Sometimes does happen, but I really don't know exactly what I'm going to do. Anyway, enough for now. I'll get back to you real soon. Thanks for watching, and if you like this sort of thing, please subscribe. It's good for the ego.